Session 5.2 Verifying Trigonometric Identities. We need to know how to verify identities by working on one side or working with both sides. And we do have the guidelines for verifying trigonometric identities. I show you the first example. Like this one. Example 1. Verify the following equation is an identity. Means I want you guys to prove the left hand side that will be equal to the right hand side. This is the equation. So let's look at the guidelines. First, work with one side of the equation at a time. It is often better to work with one more complicated side first. So you do have the equation. You're going to look at it, which part will be more complicated. Then you're going to start with that part. Second, look for the opportunities to factor an expressions, add fractions, square a binomial, or create monomial denominator. For example, the expression sine squared x plus 2 sine x plus 1. So when you see something like this, you should be able to factor out like this guy. Okay? Or when you see two fractions add up together, what you're going to do? You want to find the common denominator. Okay, find out the LCD. So the LCD will be sine x and cosine x. Okay, try to combine it together. Number 3, look for the opportunities to use the fundamental identities. Look which functions are in the final expressions you want. If you're working on the left hand side, you try to make it like become to the right hand side. You may want to use the formula also. Okay, just like this one, you know that sine squared theta plus cosine squared theta equal to 1. So this is the identities you could apply it when you were verifying the trigonometric identities. Also, the tangent squared plus 1 equal to secant squared. 1 plus cotangent squared equal to cosecant squared. Okay, I need you guys to remember all these identities. Number 4, if the preceding guidelines do not help, then try converting all terms to sine and cosine. Okay, sometimes they may give a tangent, secant, cotangent, cosecant. If it doesn't work from the previous step, you may want to try convert all of them to the sine and the cosine. Number 5, always try something. Even making any attempt that leads to a dead end can provide insights. So just try your best. Think about all the formula or convert it to the sine, cosine, or tangent, secant to see if you have any idea to make it like to the right hand side. Caution, the procedure for verifying identities is not the same as that of solving equation. So this is very important. Okay, just like the example 1 here. We do have the equation here, but when you verify the identity, you always start with one side. Either start with the left hand side or you start with the right hand side. You never combine it together. This is not the solved equation. We want to prove they are equal to each other. So you can't do like add or subtract or multiply, divide for both sides like that. Okay, let's try together. Number 1. Verify that the following equation is an identity. Cotangent theta plus 1 equal to cosecant theta times cosine theta plus sine theta. So you always start with one side, either left hand side or right hand side. Most of the time, we will try to use the complicated one. Okay, so compare for it, right hand side will be much more complicated. So we're gonna start with the right hand side here. Okay, so first, we do have a cosine and sine, but we do have the cosecant here. So we may want to try to convert the cosecant to 1 over sine. Okay, do we have any formula for that? No, right? So what we can do, we just try to distribute. Okay, distribute 1 over sine theta for both of them. Okay, on the right hand side, we are looking for the cotangent theta. Okay, cotangent theta, that will be this guy, cosine over sine, that will be equal to cotangent. And then this one, sine theta and sine theta, you could simplify it. That will be equal to 1. Okay, we good. This is also equal to the left-hand side. So we prove the identity if this is true. Okay, one more time. Always start with one side, either left-hand side or right-hand side. And try to work on the complicated one. Okay, example 2. Verify that the following equation is an identity. So this one, I will start with the left-hand side because the left-hand side is much more complicated with the right-hand side here. Okay, can you guys try to think about it? How can you make it like to 1 over 1 minus sine squared x? Okay, I will distribute the tangent square x. Now, try to simplify it. Okay, what is the relationship between tangent and cotangent? Cotangent x will be the reciprocal of tangent x. Okay, so plug it in and simplify it to see what you guys get. Okay, good. Simplify it. So I left with tangent square x plus 1. Okay, what is a tangent square x plus 1? Any identities? Yes, right? Tangent square x plus 1, that will be equal to secant square x. That's really good. Okay, now look at the right-hand side. First, I want the fraction. Okay, right now I only have the secant square x. Can you make it with the fraction? Secant square x will be equal to 1 over cosine square x. Okay, we're almost there. What is the relationship between cosine square x and the sine square x? We could use the identity, right? Remember, sine square x plus cosine square x equal to 1. Okay, these two guys added up equal to 1. So cosine square x will be equal to 1 minus sine square x. That's good. This is going to be equal to your right-hand side. Okay, example 3. Verify this identity. So this one I will start with my left-hand side here. Okay, since I do have the common denominator here, I want to separate into two terms. Okay, that will be tangent t over sine t cosine t minus cotangent t over sine t cosine t. Okay, it's just like the same denominator, they put it together. Okay, now I'm gonna separate it. Okay, I write one more step. I put the tangent t here. Tangent t times 1 still equal to tangent t. Cotangent t times 1, that's gonna be equal to cotangent t here. Okay, I try to make it they are the same thing here. I do have a tangent, sine, and cosine. I can't simplify it. Let me try to change the tangent into sine over cosine. Same idea with the cotangent t. That will be cosine t over sine t. Okay, plug it in. Now, simplify it. This is a multiplication. Okay, I only can simplify this term. Okay, this is a multiplication. So sine t and sine t, I could simplify it. And then minus cosine t over sine t times 1 over sine t cosine t. So this is a multiplication again. So I could simplify the cosine t here. Now, I left with 1 over cosine squared t minus 1 over sine squared t. Okay, look at the right-hand side. 1 over cosine squared t, that will be equal to the secant squared t. 1 over sine squared t, that will be equal to cosecant squared t. That will be equal to your right-hand side. So we proved the identity. Okay, example 4. Verifying an identity. This one, you could start with the left-hand side or you could start with the right-hand side. They do have the same approach. So for me, I will start with the left-hand side here. Cosine x over 1 minus sine x. You may say, hey, that's a no formula here, and that's a no square, no identity. So what can I do? So when I look at this guy, I have a 1 minus sine x here. I will multiply the conjugate of the denominator. Remember what's the conjugate? Just like when you have a plus b, the conjugate of a plus b will be a minus b. Okay, when I have a minus b, the conjugate of a minus b will be a plus b. Okay, so what is the conjugate of 1 minus sine x? That will be 1 plus sine x, right? So I'm gonna multiply by 1 plus sine x over 1 plus sine x here. So on the top, I won't distribute it because I look at my right hand side, I do have a 1 plus sine x here. I already have the 1 plus sine x on the top. So I will keep this one on the numerator. And then on the bottom, 1 minus sine x times 1 plus sine x. Remember, you guys learned it from the algebra. A minus b times a plus b. That will be equal to a squared minus b squared. Okay, so this is a minus b times a plus b. So you should have a 1 square minus sine square x. Okay, and then what is a cosine square x and sine square x? The identity. Cosine square x equal to 1 square minus sine square x, right? So I could replace this guy with the cosine square x. And then multiplication, so I could simplify it. Take out 1 of the cosine x. Okay, this guy, that will be equal to your right-hand side. We verify the identity. Okay, this is a really good approach that when you have nothing to do here, you could multiply the conjugate to see. Verifying identities by working with both sides. If both sides of an identity appear to be equally complex, the identity can be verified by working independently on each side until they are changed into a common third result. So I may start with the left hand side a little bit until I got something. I got another expressions. Then I will start with the right hand side again here, and then until I get to the third expressions, I would say left hand side will be equal to the right hand side. Okay, this is another approach for verifying identities. Let's look at this example. Okay, you could see both of them are pretty complicated, right? I would just try to start with the left hand side first. And then since my right hand side, I do have a cosine sign here. Okay, and secant means 1 over cosine, and tangent, that's sine over cosine, right? So I will strictly multiply by cosine x over cosine x together. And then I'm gonna distribute one by one. Okay, distribute to cosine x, distribute to cosine x. Now, I will try to simplify it. Secant means 1 over cosine. Tangent, that'll be sine over cosine, right? Plug it in. And then we're gonna simplify it. Okay, cosine cancel out. So I'm left with 1 plus sine x over 1 minus sine x. Actually, from here, I could multiply the conjugate of 1 minus sine x again, okay? But if you have no idea to work on it, you could just stop here, okay? I start with the left-hand side and then I stop here. Now, I'm gonna start with the right-hand side again. And then on the top here, I should be able to factor out this guy. You should get 1 plus sine x squared. And then, you know cosine squared x equal to 1 minus sine squared x. That's by the identity. Okay, now on the denominator, I should be able to factor out this guy. This is a squared minus b squared. Okay, a squared minus b squared equal to a plus b times a minus b. Okay, now I could simplify one of the 1 plus sine x. Now, my right-hand side, I start with the right-hand side until I got this guy. Okay, this is exactly the same thing from the previous slide. I start with the left-hand side. So, I'm gonna write it down. I start with my left-hand side and I got this one here. And then I start with the right-hand side, I also equal to this one. So, I would conclude that left-hand side, that would be equal to right-hand side. Okay, that's it.